In this video, we're going to derive some exponent rules so that we can quickly evaluate expressions that involve exponents. Let's consider a cubed times a squared. We could think of this expression as a times a times a times a times a, which would result in a to the fifth. We should note that that's the same thing as a to the 3 plus 2. This shows us what we would call the product rule. Assuming you have the same base, in this case a to the b times a to the c will result in a to the b plus c. So now if we want to evaluate a cubed times a squared, we could simply evaluate that as a to the 3 plus 2 is a to the fifth power. Let's consider now a squared raised to the third power. This could be rewritten as a times a times a times a times a times a, which would result in a to the sixth power. We should notice that that's really like doing a to the 2 times 3. This shows us what we call the power rule. If we had a to a power of b raised to a power of c, this results in a to the b times c. If we now go back to our original expression, we could instead evaluate this as a to the 2 times 3, which would again result in a to the sixth. Now let's consider a to the fifth over a squared. We could rewrite this expression as a times a times a times a times a in the numerator over a times a. The result is that this a times a in the denominator would cancel out in a times a in the numerator, and we would end up with a cubed. This shows the quotient rule, which is that if you have a to a power of b over a to a power of c, the result is a to the b minus c. If we apply that to our original expression now, this would result in a to the 5 minus 2 is again a cubed. Let's now consider the expression a squared over a to the fifth power. From our previous quotient rule, we learned that this could be rewritten as a to the 2 minus 5, which would result in a to a power of negative 3. Let's instead try and rewrite this. This could be rewritten as a times a in the numerator, and then we could rewrite a to the fifth in the denominator. The result is a times a in the numerator would cancel out a times a in the denominator, and we would get 1 over a to the third power. This shows the negative exponent rule, that if you have a raised to a negative b, the result is actually 1 over a to a power of b. Let's try and apply the quotient rule again. This time we have a cubed over a cubed. This would result in a to the 3 minus 3, which is a to the 0 power. Well, if we think about a cubed over a cubed, any number divided by itself actually results in 1. This shows that a to the 0 power is in fact actually 1. This is our zero exponent rule. Anything to a power of 0 is actually just 1.